Hello everyone, I am Dr. VRAO. In the last videos of electrochemistry, we had gone through the electrolytic cell, electrolysis and Faraday's laws of electrolysis. And I already told you that electrochemistry deals with the conversion of electric energy into chemical energy. Conversion of electrical energy into chemical energy and conversion of chemical energy into electrical energy. Okay, so in the last classes of electrochemistry, already we had gone through the conversion of electrical energy into chemical energy, which can be done by electrolytic cell. We had gone through it already, right? Today we shall go through the conversion of we shall deal with the conversion of chemical energy into electrical energy, which can be converted by or which can be done by galvanic or voltaic cell, which can be done by galvanic or voltaic cell, galvanic or voltaic cell, right? And this can be done by electrolytic cell. This can be done by electrolytic cell, right? So today we shall deal with the galvanic or voltaic cell. Let us know what is meant by galvanic or voltaic cell. Let us know what is meant by galvanic or voltaic cell. Galvanic or voltaic cell, when two dissimilar metals placed in aqueous solutions of salt or an acid, which behaves or which becomes as a source of electricity. I repeat, when two dissimilar metals are placed in aqueous solution of salt or an acid, which becomes or which behaves as a source of electricity. Okay, and that source of electricity is called as a galvanic or voltaic cell, right? So galvanic or voltaic cell is a source of electricity, right? So in the honor of the great scientists Galvani and Voltaic, in the honor of the great scientists Galvani and Volta, they termed the type of cells are termed as galvanic or voltaic cells, right? So the best example for galvanic or voltaic cell is Daniell cell. Best example for galvanic or voltaic cell is Daniell cell, right? So let me pose one question. What is galvanic or voltaic cell? Galvanic or voltaic cell is a source of electricity, and the best example for galvanic or voltaic cell is Daniell cell, right? So in Daniell cell, that two dissimilar metals are zinc and copper. That two dissimilar metals are zinc and copper. Already we know that galvanic or voltaic cell. Okay, what is galvanic or voltaic cell? When two dissimilar metals are placed in solution, aqueous solution of salt or an acid, that behaves or that becomes as a source of electricity. So that two dissimilar metals in Daniell cell are zinc and copper, and these two are placed in zinc sulfate and copper sulfate solutions. okay, and that behaves as a source for electricity, right. So let us see the construction of a Daniell cell, right, construction of a Daniell cell, right. Daniell cell in which zinc rod dipped in zinc sulfate solution, 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 and copper rod dipped in copper sulfate solution. Right, okay, this is zinc rod and zinc rod dipped in zinc sulfate solution. This is the zinc sulfate solution, okay, and this is the copper rod and this is copper sulfate solution. This is copper sulfate solution, right. So when these two electrodes are connected by a wire to ammeter, and these two, actually these two are called as two compartments. This is one compartment and this is another compartment, and these two compartments are connected by U-shaped, inverted U-shaped glass tube filled with KCl solution. Usually we call it as a salt bridge, and these two compartments are connected by a salt bridge. So what is salt bridge? Salt bridge is inverted U-shaped glass tube filled with KCl solution, right. So KCl solution. So when so these two, zinc rod and copper rod connected to ammeter, and these two compartments are connected by the salt bridge. Okay, as soon as circuit is closed, that is when these two are connected to ammeter and these two are connected by a salt bridge, that is as soon as circuit is completed, okay, there is a start of flow of electricity. Okay, there is a as soon as circuit is closed, that results flow of current, that results that as soon as circuit is closed, that starts or consequently flow of current takes place, which is indicated by deflection in ammeter. How can we know there is a flow of electrons or flow of current? That is indicated by the deflection in ammeter. We know that ammeter is a device which measures the current. So deflection in ammeter indicates there is a flow of current through this electrodes, through cell, right. Okay, so but the flow of current is accompanied by redox reactions. Already I told you that electrochemistry deals with conversion of electric energy into chemical energy by Daniell cell, right. So Daniell cell is a source of electricity, and thereby the Daniell cell is a source of electricity, and as soon as the circuit is completed, there is a flow of electron, there is a flow of current, and the flow of current is accompanied by chemical reactions, because here the chemical energy is converted into electrical energy, right. So, the flow of current is accompanied by the following reactions. The zinc rod dipped in zinc sulfate solution, undergoes oxidation. Zinc rod dipped in zinc sulfate solution undergoes oxidation. Oxidation means loss of electrons. Okay, and the loss of and owing to the oxidation, Zn plus 2 ions goes into the zinc sulfate solution. Zn plus 2 ions goes into the solution, and electrons move into the ammeter. Zn plus 2 ions goes into the zinc sulfate solution, and electrons move into the ammeter and thereby enter into the copper rod. Owing to the availability of electrons, how there is a availability of electrons, zinc undergoes oxidation. Owing to the oxidation, Zn plus 2 ions goes into the solution, and electrons move into the ammeter and thereby enter into the copper rod. Right. So, here copper rod, there is availability of electrons. Due to that availability of electrons, the Cu plus 2 ions in the copper sulfate solution undergoes reduction. So, due to the availability of electrons on the copper rod, the Cu plus 2 ions comes onto the copper surface and they gain that electrons and undergoes reduction. So, Cu plus 2 ions gained that electrons, okay, undergoes reduction. Okay. So, each Cu plus 2 ion gained 2 electrons and deposited as copper on the copper rod. Okay, right. So, electrons flow from left to right, that is, electrons are generated at zinc electrode, and that electrons flow to the ammeter and thereby enter into the copper rod, and where due to the availability of electrons, Cu plus 2 ions undergoes reduction, right, Okay. So, electrons flow from left to right, electrons generated at zinc electrode and consumed at copper electrode. So, electrons flow from left to right. Okay. So, and current is flowing from right to left because current is opposite to the conventional flow of electrons. Flow of electrons is left to right and current is from right to left, right. So, zinc undergoes oxidation and copper undergoes reduction. So, this is oxidation and this is reduction, right. So, oxidation and reduction takes place simultaneously in the Daniell cell, right. And one more thing is that the SO4 2 minus ions left, unpaired. The SO4 2 minus ions left unpaired due to Cu plus 2 ions got reduced due to Cu plus 2 ions. The Cu plus 2 ions present in the solution goes onto the copper surface where that Cu plus 2 ions gained 2 electrons and deposited on the copper electrode surface. Okay, so owing to that SO4 2 minus ions left unpaired, SO4 2 minus ions left unpaired. These SO4 2 minus, thus SO4 2 minus ions in the copper sulfate solution left unpaired, and they migrate to the another segment, and they migrate to the another segment, by through this salt bridge. So these SO4 2 minus ions migrated to another segment through this salt bridge, where SO4 2 minus ions serve as partners for Zn plus 2 ions, right? Partners for Zn plus 2 ions. So thereby complete the circuit. Okay, that completes the circuit, right? So SO4 2 minus ions migrate to the another segment through this salt bridge, where they are partners for, they serve as partners for Zn plus 2 ions, and this completes the circuit. So electrons flow from left to right, and current is flow from right to left, and the SO4 2 minus ions left unpaired migrated towards Zn plus 2 ions through salt bridge. That completes the circuit. So oxidation takes place at zinc electrode. This is called oxidation. Due to this oxidation, there exists a potential between zinc rod and zinc sulfate solution. Due to this oxidation, there is a potential exists between zinc rod and zinc sulfate solution. How? Because due to oxidation of zinc, Zn plus 2 ions comes into the solution. Due to already this is zinc sulfate solution and there is a Zn plus 2 ions, but owing to the oxidation of zinc, more number of Zn plus 2 ions goes into the solution. That's why the concentration of zinc sulfate solution increases. Right? That means it acquires, this solution acquires positive charge and this electrode acquires negative charge. So positive charge, negatively charged electrode and positively charged solution. So there exists a potential between this electrode and this zinc electrode and this zinc sulfate solution, that is called oxidation potential. Right? And here the copper Cu plus 2 ions deposited on the copper surface, on the copper rod, liberated and leaving SO4 2 minus ions unpaired. So this electrode becomes positively charged because this solution is negatively, all the Cu plus 2 ions are get reduced by the by taking 2 electrons from zinc rod. So in this solution becomes negatively charged and this electrode is positively charged, and this is copper rod is positively charged and copper sulfate solution is negatively charged. So there exists a potential between copper rod and copper sulfate solution, and that potential is called reduction potential. Okay, so net chemical reaction is zinc undergoes oxidation and copper rod undergoes reduction. Okay, these two electrons get cancelled. Zn plus, whenever you write the plus 2 ions, you should write aqueous. aqueous, and this is actually it is a reversible reaction, it is a reversible reaction, and Cu plus Zn plus 2, Zn plus 2 aqueous. Because why we are writing aqueous, here Cu plus 2 aqueous, Cu plus 2 ions got reduced as copper, and going to the oxidation of zinc, Zn plus 2 ions comes into the zinc sulfate solution. So, plus 2 ions, Zn plus 2 ions are in the aqueous solution, and Cu plus 2 ions are in the aqueous, remains in the aqueous solution. That is why we should write Cu plus 2 aqueous and Zn plus 2 aqueous, right. So, this is the net chemical reaction, that is zinc undergoes oxidation, copper undergoes reduction. So, redox reaction, redox reaction and reduction and oxidation takes place simultaneously, right. Due to this redox reaction, there is a production of electricity, there is a production of electricity, right. So, Daniell cell is a device which makes use of spontaneous redox reaction for the generation of electricity, right. So, Daniell cell is a device which makes use of spontaneous redox reaction for the generation of electricity. So, Daniell cell is the best example for galvanic or voltaic cell, and galvanic or voltaic cells are acts as a source of electricity. That is why Daniell cell is also a source for electricity. Then what you should understand the point is, when zinc rod dipped in zinc sulfate solution, it undergoes oxidation. Owing to that oxidation, Zn plus 2 ions goes into the solution. So, during the functioning of Daniell cell, the concentration of zinc sulfate solution increases. The concentration of zinc sulfate solution increases, right. And okay, concentration of zinc sulfate solution increases, and this is the compartment where the oxidation takes place. That is why this compartment is called oxidation compartment. So, in this oxidation compartment, the concentration of zinc sulfate solution increases, right. And this is the another compartment where the reduction takes place, that is why we call it as the reduction compartment. Okay. So, here the during the functioning of Daniell cell, the Cu plus 2 ions goes on reducing. That is why the concentration of Cu plus 2 ions decreases. That is the concentration of copper sulfate solution goes on decreasing, and that is concentration of zinc sulfate solution increases and the concentration of copper sulfate solution decreases, and there is a flow of electrons from left to right, that is zinc to copper, and electricity is from right to left, right to left. So, from zinc to copper, electrons takes place, there is a flow of electrons from zinc to copper, and current is flowing from copper to zinc. And one more thing is that when zinc rod dipped in zinc sulfate solution, there exists a potential, between zinc rod, because this zinc rod acquires negative charge and this zinc sulfate solution acquires positive charge. So, negatively charged electrode, positively charged solution, and there exists a difference, and that difference is called oxidation potential. So there exists a potential between that two, that potential is called oxidation potential, right? And copper undergoes reduction, Cu+2, and the copper rod acquires positive charge and the solution acquires a negative charge. So there exists a potential between copper rod and a copper sulphate solution, that is called reduction potential. Okay, and so due to oxidation, this zinc rod acts as anode, and copper acts as a cathode. Okay, copper acts as cathode. Here in the Daniell cell, anode means negatively charged electrode, cathode means positively charged electrode. But whereas in the electrolytic cell, anode means positively charged electrode and cathode means negatively charged electrode. You should remember this point. That is the fundamental difference. That is the difference between the representation of electrolytic cell and representation of electrodes in electrolytic cell and in galvanic cell. So in the galvanic cell or Voltaic cell, or more conveniently we call it as in Daniell cell, anode is negatively charged electrode and cathode is positively charged electrode. But whereas in the electrolytic cell, anode means positively charged electrode, cathode means negatively charged electrode, right? So here there exists a oxidation potential and there is a reduction potential, and the EMF and there is called EMF is there for this cell. EMF means EMF, electromotive force. That means it is a force to motivate the electrons towards higher potential. So EMF is a force to motivate the electrons towards higher potential. So electrons move from left to right. So here the potential is high. So it is a force to motivate the electrons towards higher potential. It is the force to motivate the electrons towards higher potential. So where the potential is high is there, because this electrode acquires positive charge. More positive charge means more potential, right? More positive charge means more potential, because that's why electrons move towards higher potential electrode, that is copper electrode. So EMF is a force to motivate the electrons towards higher potential. Where the potential is high, where the positively charged is high, where the positive charge is high. Okay, where the this is the electrode with more positive charge. So this electrode has more potential. Okay, so EMF of the cell is potential at the right hand electrode minus potential at the left hand side. Okay, so EMF is potential at the right hand side minus potential at the left hand side. Okay, but there is a condition is these two potentials are, that is oxidation potential and reduction potentials are reduction potential, or these two potentials are reduction potentials, and we can convert the reduction potential into oxidation potential and oxidation potential into reduction potential. Simple. Oxidation potential, if you have the oxidation potential value, and we can get the reduction minus reduction potential. Reduction potential. Okay. Oxidation potential is equal to minus reduction potential. If we have oxidation potential, if you multiply with the negative sign, then that becomes a reduction potential, right? So these two are reduction potentials. Okay. EMF, we can give the EMF equation in terms of oxidation potentials. In terms of oxidation potentials, in such case EMF is equal to ELHS minus ERHS. Here the two potentials are oxidation potentials. Here the potentials are oxidation potentials, right? Here the potentials are oxidation potential, and there is another equation for EMF. EMF is equal to E oxidation potential plus E reduction potential, where this is oxidation potential and this is reduction potential. Okay, if the two potentials are reduction potentials, so to get the EMF of the cell, just we subtract potential, reduction potential at right hand side minus reduction potential at left hand side. If we have oxidation potentials and we want to calculate the EMF, then we subtract oxidation potential at left hand side minus oxidation potential at right hand side, and we have oxidation potential at left hand and reduction potential at right hand, then we add that two potentials, we can get the EMF. We can get the EMF, right? So this is the calculation for EMF. Okay, so the fundamental difference between electrolytic cell and Daniell cell, already I told you, electrolytic cell is a device which converts electrical energy into chemical energy, where the anode is positively charged electrode and cathode is negatively charged electrode, right? And Daniell cell is a device which converts chemical energy into electrical energy, where the anode is negatively charged electrode and cathode is positively charged electrode. Okay, and in the Daniell cell there is a flow of electrons from left to right. Why right? Because electrons always moves towards higher positive charge side, right? Higher positive side, higher positive charge electrode side. That's why electrons left to right. That's why. Next, representation of Daniell cell. So as per the IUPAC convention, right, the electrode where the oxidation takes place is always right at that should be written at left hand side. That is here the zinc rod, dipped in zinc sulfate solution, that is zinc rod in contact with the zinc sulfate solution, that is being represented as zinc in contact with the zinc sulfate, that is Zn+2 ions. This single line indicates the zinc is in contact with the zinc sulfate solution, and Cu+2 ions are Cu+2 ions are in contact with the copper rod, that is being represented with the Cu+2 ions are in contact with the Cu, right? And this salt bridge is being represented with two parallel lines. That two parallel lines indicates the salt bridge. The two parallel lines indicates the salt bridge, right? Okay, so this is the representation of Daniell cell. Okay, always write the electrode where the oxidation takes place should be written at left hand, and the electrode where the reduction takes place should be written at right hand side, and that two electrodes are joined by the two parallel lines, that is salt bridge. That two parallel lines indicates the salt bridge, right? Okay, so this is about Daniell cell. This is about Daniell cell. So Daniell cell, let me conclude this lecture. Daniell cell is a device which makes use of spontaneous redox reaction for the generation of electricity, right? So in the next classes we shall go through the single electrode potential. Already I told you that this is the oxidation potential and this is the reduction potential. In the next videos we shall go through the potential, electrode potential, standard electrode potential, oxidation potential, reduction potential. Okay, in the next classes we shall go through that. We shall deeply involve in that what is it called, oxidation potentials and reduction potentials, because those are very important in understanding the electrochemistry problems. Thank you for watching.